Machine learning libraries play a crucial role in simplifying the implementation of complex algorithms and models. And in this video, we'll tell you about 7 libraries you must know for machine learning. We'll discuss each library along with its use cases and the pros and cons that come with them. On this note, let's begin. There are few things you must keep in mind while choosing a library for machine learning. First, the library should be easy to use with comprehensive documentation. Second, it should be efficient and capable of handling large dataset. Third, it should be flexible enough to support various algorithms and models. Fourth, it should have an active community of developers who can help you if you get stuck. Finally, the library should seamlessly integrate with other popular libraries in the ML ecosystem. Keeping all of these in mind, let us look at the best libraries for machine learning that are out there. Our first library is NumPy. This is a fundamental library for scientific computing in Python. It supports large multi-dimensional arrays and matrices and has a collection of mathematical functions to operate on these arrays seamlessly. And if you look at the use cases, NumPy is extensively used in various machine learning applications, including image processing, natural language processing, and data analysis. Talking about pros, NumPy has efficient array operations and mathematical functions. Plus, it can easily integrate with other libraries like Pandas and Matplotlib and comes with extensive community support as well. However, it has limited support for high-level data structures, which is a con. Here's the NumPy documentation that you may refer to for getting started. The second library we'll look at is Pandas. It is a powerful library for data manipulation and analysis. This is because it provides data structures like data frames and series for efficient structured data handling. Plus, Pandas are extensively used in data pre-processing, feature engineering, and exploratory data analysis. It enables tasks such as data cleaning, missing value imputation, and data aggregation. If we look at the pros, Pandas are extremely efficient in data manipulation and analysis capabilities. Plus, it can integrate with other libraries like NumPy and Matplotlib for seamless data analysis and visualization. Plus, it has a rich set of functions for data pre-processing and exploration. However, the con would be that it can be memory intensive for large datasets. Here's the Pandas documentation that you may refer to for getting started. Third library in our list is Matplotlib. This is a popular library for data visualization in Python and provides a wide range of functions and classes for creating various types of plots, including line plots, scatter plots, bar plots, and histograms. Plus, this library is highly customizable and allows for detailed control over plot aesthetics. Due to all of this, Matplotlib is extensively used in machine learning for visualizing data distributions, model performance, and feature importance. Additionally, it enables the creation of informative and visually appealing plots that aid in data exploration and model interpretation. The pros are that there is a wide range of plot types and customization options in Matplotlib. Plus, integration with other libraries for data visualization is pretty seamless. Additionally, there is an active community and extensive documentation on Matplotlib which is available out there. However, there is one con, which is limited interactivity in plots. By the way, do not forget to check out this documentation for Matplotlib. Fourth library in our list is Scikit-learn, which is a comprehensive machine learning library that provides various algorithms and tools for various tasks, including classification, regression, clustering, and dimensionality reduction within machine learning. It offers a consistent API and is used in machine learning projects for classification, regression, and model evaluation tasks. Additionally, it comes with a rich set of algorithms and functions for feature selection, model training, and performance evaluation. And guess what? Scikit-learn also offers utilities for data pre-processing, cross-validation, and hyperparameter tuning. A major pro of Scikit-learn is that it has a wide range of machine learning algorithms and tools. Not just that, it comes with the consistent API and integration with other libraries. Additionally, it also has extensive documentation and community support. However, its limited support for deep learning algorithms can count as a con. Guys, as usual, here's the documentation for Scikit-learn that you may refer to for getting started with Scikit-learn. The fifth library in our list is SciPy. It provides various functions and algorithms for numerical integration, optimization, signal processing, and linear algebra. If you talk about the use cases, SciPy is extensively used in machine learning for optimization, signal processing, and statistical analysis tasks. Plus, it offers functions for numerical integration, interpolation, and solving differential equations. SciPy also provides statistical distributions and hypothesis testing functions, making it a valuable tool for data analysis and modeling. Like Scikit-learn, SciPy has wide range of scientific computing functions and algorithms. Along with that, it can be integrated with other libraries like NumPy and Matplotlib. SciPy builds on top of NumPy and provides additional functionalities for scientific computing tasks. It also comes with an active development and community support. Con would be that it has limited support for deep learning tasks. Here's the documentation for SciPy that you may refer to. Sixth library is PyTorch, which is a popular deep learning library that provides a flexible and efficient framework for building and training neural networks. It offers dynamic computational graphs, automatic differentiation, and GPU acceleration. Now, PyTorch is extensively used for deep learning projects for tasks such as image classification, object detection, and natural language processing. If you are wondering why, well, this library provides many pre-built neural network architectures, modules, optimization algorithms, and loss functions. Not just that, PyTorch also supports transfer learning and model deployment on various platforms. A big advantage of PyTorch is that it has a very flexible and efficient deep learning framework. Along with that, it has dynamic computational graphs and automatic differentiation. Like many libraries mentioned here, this also has an active community and extensive research support. However, a major hindrance is that it has limited support for distributed training. Anyway, this is the documentation for PyTorch that you may begin with. The last library we have for you is Keras. It is a high-level deep learning library that provides a user-friendly interface for building and training neural networks. Keras offers a wide range of pre-built layers, activation, and loss function. This makes creating complex neural network architecture very, very easy. Plus, Keras supports CPU and GPU acceleration. This library has quite a few use cases. First is you can use it in deep learning projects for various tasks like image recognition, text classification, and generative modeling. Secondly, it provides a simple and intuitive API for defining and training neural networks, allowing rapid prototyping and experimentation. Third, Keras also supports transfer learning and model deployment on various platforms. If we talk about the pros, Keras is a user-friendly and intuitive deep learning framework, has an extensive collection of pre-built layers and functions, and integration with other deep learning libraries like TensorFlow, which is seamless as well. Major con for Keras would be that it has limited low-level control compared to other libraries. Here's the Keras documentation that you may refer to for getting started. Guys, that's all we have for you today. If you have any questions, let us know in the comment section and we'll get back to you. We'll leave a bunch of articles on the libraries that we discussed in the description part below, along with the links to documentations, of course. If you liked our work, subscribe to our channel for more such interesting data tech content. See you in the next video. Bye.